Hello everyone. So today we have a problem statement where we need to find the duplicates, right? If we see the very first example, so this is the first example where we have 1, 2, 3, 4 in an array, and we have to check whether any of these elements has been duplicated in the same array. So if we check, so there each and every element is unique here, right? So 1 is unique, 2 is unique, 3 is unique, and 4 is unique. So output should be false. There is no duplicate, right? Now if we go to the second example, we have 4 elements, 1, 2, 3 and 1. So if we see 1 has been duplicated over here, so that means output will be true because here we have one duplicate element. Now let's go to a third example, that is we have 3, 2, 6, minus 1, 2, 1. Again if we see we have one element, this 2, right? This has been duplicated, so again output will be true. So now let's dive into the solution first, how we can solve this problem. So let's say again we have the array, and now let's write the index number as well. So it is 0, this is 1, this is 2, this is 3, this is 4 and this is 5. So now if we see what we can do, like we can check for each and every element if it has been duplicated. How we can do that? So let's take one variable, let's say this is I, okay? So in I will be taking each and every element of this array. Now for each and every element I'll check for other elements. So let's say for the I'll take 3. I'll take another one variable, let's say j. For this one we'll check for each and every other position. So for this position, okay, we'll check for this one, okay, I'll compare it with this one, okay. So for 3 I'm comparing with j equal to 1, I'm checking whether it is equal, no, okay. Then I am checking j equal to 2, means this one, array of 2, okay. I am checking is it equal, no. Then I am checking array of 3, if this is equal, no, 3 is not equal to minus 1, then this is also not true, okay. Then I am checking for 4, this is also not equal, correct. Then I am checking for 5, so this is also not equal because 3 is not equal to 1. So for I equal to 3, we have checked that 3 is not duplicated, correct. So the similar way we'll do for other element as well, okay. Let's again draw it. So now our I value got changed to 2, correct. So now I'll check with for this one, for this particular variable, okay. Let's say again from j we will be starting from the very next element, correct. So j will be 2. So I'll check with this one, is this equal, no. Then I'll check with the position 3, is this equal, no. Then I'll check with the fourth position, is this equal, yes, it is equal. So that means here our output will be true. This approach where we are checking for each and every element, we are checking for other elements, this approach is called brute force approach. Let's code it out. So now we have one method which will basically return boolean, correct. Method name, let's say keep it is duplicate, and here what is passing, one array variable, okay. I'll share all of this code in the description. So now what we are doing, first we are taking one position and we are checking for other position. Use one for loop where I should be equal to from the starting position, I equal to 0, I could be less than num dot length, and I'll increase this I. Now for each and every element we'll check for other position. So see here the way we are checking, correct, for other elements. So let's again we need to apply another one loop. Say j equal to, we don't need to check for that same position, okay. So it should be like I plus 1, okay. Then j should be again less than num dot length and j plus plus, okay. Now under this loop we'll check position of that array, means num of I is equal to num of j, okay. Then what we'll do, we'll simply return true from here because we don't want to proceed any further. That's why we will break and return true from here. We'll end the second loop, we'll end the first loop. Let's take this example because here we will pass through all the element but there is no duplicate. So in that case, basically this for loop will run for the whole iteration, correct? And there will be no duplicate. Basically this particular if block will never executed in that case. Return false and end this method. And if you want, I can dry run it for that scenario where we don't have any duplicate. So again, for loop here I equal to 0 first and j is equal to 1. If I'm checking if 0 is equal to 1, this one and this one, no, then I'm increasing the value of j. Is this is equal to this? No, I'm checking j equal to now 3. If this is equal to this one, no. Now again come back to this one, this for loop. Let's increase the I value to 1. Increase the I value to 1. So now I'm checking for this particular variable. J will be starting from I plus 1, means j will be starting from 2. This one is equal to this one, no. Increase the j value to 3. Is this is equal to this one? No. Now again increase the I value to 2. Then j value will be 2 plus 1, 3. I am comparing. If this is equal to this one, no. Increase the j value to 4. It is not less than num plus length. Now let's increase the I value to 0, 1, 2, 3. J will be 4. Okay. 4 is not less than num dot length. Then j loop will not get executed. That means in this case, this particular if block will never get executed and at the end will simply return false. Now let's calculate the time complexity for this. So we have one for loop. Which is running for n element, correct? And the second loop, it will be running for n minus I minus 1. Why? Because already it will start from 1 plus of this I. Okay, so that's why it will be minus 1. And it should be also minus I because it should be starting after I. Okay, so this loop will be running for n and this loop will be running for this much. Okay, then what is the time complexity for this one? It is big O of n into n minus I minus 1. So we can simplify it as, because we have to take the maximum, correct? We can simplify it like big O of n square. So this is the time complexity. Now let's discuss about the space complexity. So if we see, we are not storing anywhere any result. Although we are using couple of variable like I, j. So these are the two variable we are using. But still, if we see, these are the constant space. Okay, it is not increasing neither decreasing with the input size. Okay, so these are like the constant space. So we can say that space complexity is big O of 1. So the same problem we have, we can use another one approach. Okay, we can use one thing called the hash set. Okay, and how it can help, so let's see. So again we'll take the same input example. So here if we see, again 2 and 2 is duplicate. Here we'll take a different approach. We'll use the hash set, and we know the property of hash set is that it will always contain the unique element. So let's say we'll have a hash set named as set. Okay, so it is our hash set. So initially it is empty, it has nothing, it is empty. As it is empty, we'll check for each and every element whether it is present in the set or not. If it is present, then we'll return true. And if we pass through every element in the array and still we didn't find anything present in the set, then we'll return false. That's the main logic. Okay, so let's dry run it. So let's say again we'll take one variable I equal to 0, then that num array of 0 equal to 3. So now we are checking whether 3 present in the set or not. No, it is not present. So at this stage our set can be set as set equal to, will enter this variable as it is not present. Okay, now move to second variable. Here again I equal to 1, num of 1 equal to 2. Is 2 present in the set? No. Here I'll put it in the set. Now set will contain two variable. One is 3, another one is 2. Now let's move to that is I equal to 2 and num of 2 is 6. Is 6 present in the set? No. Then we'll put it in the set. Now set size will be 3, 2, 6. Correct. Now let's move to the next element. That is, so here num of 3 equal to -1. Is -1 present in the set? No. And again we'll put it in the set. Set will contain 3, 2, 6, -1. Now let's move to the num of 4 equal to 2. Correct. Then is 2 present in the set? Yes, it is present. We found that it is present in the set. We can directly return true. Got it? So now let's code it out and then we'll find the time and space complexity. So let's code it out. So let's take the same signature of that method and remember it. I'll put all the code in a Git repository and I'll share the link in the description. Okay. Write the method. It will be like, let's say it is a public method. Okay. Return type will be boolean and let's say method is duplicate present, and in this method we will be passing one, let's say, integer of num array. So here what we are doing, we'll have one set. It is set of integer, let's say it is set equal to new as set. Okay. So now once we have initialized the set with empty values, iterate over each and every element of that array. It is for int, say x. Okay. We will be using here for each loop. It will be little easy to understand as well as clean to write. Okay. So we will iterate over each and every element of the num. So we will be checking if that's our set dot contents of this element, and we will return true. Else what we will do, we will add that variable in the set. Okay, set dot add x. Okay, let's end our for loop. If let's say we have iterated over all the element till we will find that element in the set, then we'll simply return false. Okay. So now here if we check the time complexity. Okay. So basically this for loop, so if we check, this for loop will run for n element. Correct. Let's say num has n element, then it will check for n element. And checking here if set contains it, and we know that to fetch any element or to check element is present in a hash set, it's gonna take a constant time. Okay, so basically it's gonna take big of 1. Also take constant time. This will also take constant time. So from this we can conclude that time complexity will be big O of n plus 1 plus 1 plus 1. Okay, we can write it as big O of n. Now what is the space complexity? Here there is a change. We are using one set variable over here. It can contain up to n element because let's say there is no duplicate element. Okay, then we will store each and every element in the set. Correct. So at its highest point, set will contain at max n elements. So we can say that space complexity will be big O of n. So we understood that in our second approach, our time complexity will be big O of n and space complexity will be big O of n again, right? And at our first approach, we have the time complexity of big O of n square, which is larger, but the space complexity is constant. Now let's move further with another one approach. So now let's move to the last approach we have to solve this problem. Okay, so let's again take the same problem statement and same example so that we could understand it better. We have one array. In this approach what we will do, we will first sort this array. Okay, we'll sort this array. So if we sort this array, then what will be the output after sorting? After sort, it will become like this. So first it will be -1. Okay, then we'll have 1. Okay, then we'll have 2, then we'll have 2 again, then we'll have 3, then we'll have 6. Okay, then 0, 1, 2, 3, 4, 5. If we sort it out and we are trying to find a duplicate, okay, we can find it in the adjacent position. May not need to traverse each and every element in that array, correct? So let's say make a dry run. Okay, so here again we want to check if there is any duplicate or not, if there is any duplicate element present or not, correct? For I equal to 0, we'll check if it is present anywhere in its adjacent. Okay, so we'll check with this one, it's not equal. So like this we'll check for each and every element, correct? So for I equal to 0, it is not present. Okay, now let's say I equal to 1, which is 1, correct? Is it present? Again, no, it's not present, correct? So then again let's move to the next element, which is I equal to 2. It is 2. Is 2 present? So we'll check it from here only. Yeah, it's present. Then here it will return true, correct? So in this way we don't need to traverse at the end for this true, correct? So let's code it out. Again we will take the same approach, same signature. It is public boolean is duplicate present, and here we will pass one integer array called num. Okay, so first what we will do, we will sort this integer array, and we have one inbuilt method for this, that is arrays dot sort. So basically I am writing here Java code, and let's say you are preferring some other programming language, so there might be some inbuilt method to sort the array, correct? So here we will pass num, and once we pass this array, it will sort it out. Okay, now there is nothing over the array. For I equal to 0 and I less than num dot length -1. Why -1? Let me explain. Why I am taking it is -1? Because let's say instead of 6 here we have 3, correct? So let's say here I am checking. Okay, I need to check index 4 with 5. Okay, again I don't need to check for index 5 because at max I need to go to this n-1 element. Okay, then we can also check it with the last element, correct? So that's why I'm taking num dot length -1. We don't need to go until the last element. And here what I need to do, I just need to check if num of I is equal to num of I plus 1. If it is, then we will return true. I'll end the for loop and we will traverse through all the element, but it is not there, then we will simply return false. Okay, now let's calculate the time and space complexity. If we see, we are using one sort function over here, and we know basically the overall time complexity for this one is big O of n log n. We can mark it log base 2n, and this for loop will go until n. Now if we calculate the time complexity, it will be big O of n log n plus n. Okay, so this is the larger one, so we can write it as big O of n log n. Now let's calculate the space complexity. In general, if you see, we are not storing anything, right? So you can say that space complexity will be constant, big of 1, but that is not the case. So let's say this array sort, it is using quick sort. So in this case, what is happening, like quick sort is a recursive approach. Okay, it stores the array in a recursive stack. Okay, basically it uses the divide and conquer method based on the pivot. If you want, I can make a separate video on quick sort, but basically it stores the element in the recursive stack. So that's why that recursive stack size at max will be log of n. So you can say that space complexity of this whole algorithm is big O of log n. So for our very first approach, we have the time complexity of big of n square, but the space complexity is constant. For our second approach, we have the time complexity of big of n as well as the space complexity of big of n. And in this algorithm, we have the time complexity of big of n log n and space complexity of log n. So now if we analyze, you might say that which one is better, correct? So we can take the example. So let's analyze the time complexity, correct? For each of these approach I have discussed above. We have big O of n square, we have big O of n, we have big O of n log n, correct? Let's analyze this. And here we will take n equal to 1. Okay, so big O of n square, what? 1. Big O of n, it is 1. Big O of n log n, 1. Now let's take the n value of 2. It is 4. It is 2. It is 2 into log 2 base 2. Okay, so again it is 2. Let's take the value of 8. N equal to 8. It is 8. It is 8 into log 2 base 8. So basically it is 8 into log 2 base 8. So it is equal to 8 into 3 equal to 24. Okay, so if we just analyze, this particular big of n is the best time complexity. You can plot it in the graph and analyze. Okay, so I'll conclude this video over here, and in our next video we'll be discussing about another one problem, that is panagram. Okay, so thank you.